Hello everyone. This new topic that we're starting now, linear equations, requires us to go back and just for a few minutes start with recapping some of the basics of solving linear equations. So that's what this video is going to be about. We're going to start with the really simple linear equation that we all know how to solve already, and we'll build up to a couple of the more complicated ones, finishing off with a couple of worded problems. And this is all the basis that we need to make sure that we have in order to then progress further with this topic. So starting with solving simple linear equations, let's say I have this equation, 6x plus 21 equals 33, and we're solving to find x. Now I'm sure that everyone has a method of how to solve this, and for a lot of us we can probably do that mentally just by looking at it. I want to go through a step-by-step process just so that we can all create a common language around these sorts of things. So we want to end up at the bottom with something that says x equals. In order to do that, we need to isolate x, or we need to get rid of all the things that are on the left-hand side of the equation with x. We need to get rid of them. So we need to get rid of this 21 and this 6. When we're getting rid of these things, we always need to start with the items that are furthest away from the thing we're trying to isolate. So the furthest away from x. And when I say furthest, I mean mathematically furthest. So with this equation, 6x plus 21, we would first multiply x by 6, and then we would add 21 to that result. That means that the 21 is further away from the x. So we're going to start by getting rid of the 21, and the way we're going to do that, we can get rid of the 21 by minusing 21, because 21 minus 21 equals 0. Now, in order to keep this as an equation where both sides of the equal sign actually equal each other, we then need to minus 21 from the right-hand side as well. This gives us 6x equals 33 minus 21 is 12. Now I can get rid of the 6, and I'm going to do this by dividing both sides by 6. That gives me on the left-hand side, 6 divided by 6 is 1, so that just gives me a 1x, and 12 divided by 6 equals 2. 1x is just x, so I end up with my answer, x equals 2. Let's build up from this and start with an equation, move on to an equation that contains brackets. So first equation with brackets we're going to look at is this one. This one I can think of as pretty much the exact same thing as we had on the last slide, where I need to isolate x, and I'm going to do that by moving everything away from x, starting with the things that are furthest away. Except in this case, I would, if I'm doing this equation, I would first do x plus 2, and then I would multiply that result by the 3. Which means that the 3 is actually the furthest away from x in this case. So I'm going to get rid of that 3 by dividing both sides of the equation by 3. That means that this 3 and this 3 will cancel, giving me 1 times x plus 2 equals 18 divided by 3 is 6. And timesing something by 1 keeps it the same, so I can just write that as x plus 2 equals 6. And now I get rid of the 2 by minusing 2 from both sides, so x equals 6 minus 2, which equals 4. Okay, the next equation that we're going to do involving brackets, that method isn't really going to work for us. So let's say we have this, 3x plus 2 minus 2 x plus 1 equals 9. Let's say this is my equation. Looking at that, I can't just get rid of that 3 and that 2 to start off with, because we've got 2 sets of brackets there. And so the easiest thing to do in this case is going to be to expand both sets of brackets. So just quick reminder, when I expand brackets, I need to multiply the number at the beginning of my bracket by both of the things inside. So I'm going to get 3x. Then I'm going to do my 3 multiplied by 2 to get plus 6. Now, when it comes to this minus sign over here, I'm not going to think of this as minusing this whole thing. I'm going to think of it as a negative 2. That's going to help me with this expansion. So I'm going to do negative 2 times x gives me negative 2x, and negative 2 times 1 gives me negative 2, and that all equals 9. Now I can collect my like terms. So I've got a 3x and a minus 2x. That's just going to give me 1x. And I've got a plus 6 and a minus 2. So that's going to give me a plus 4 equals 9. And now I can solve this by doing x equals 9 minus 4, which is 5. Okay, so the key idea there is when we have a more complicated situation with brackets where maybe there's 2 of them, it's sometimes easier to expand all the brackets before I start actually solving. Let's move on to a case where we have variables on both sides of the equation. So it might look something like this. When I have an x, my variable, on both sides of the equation, the first thing I want to do is move them so that they're all on one side of the equation before I can start actually solving. Just a word of advice, when we are moving the variables so that they all end up on the one side of the equation, it's often easiest if I keep my variables positive. And what I mean by that is we have to decide, are we going to take the 2x over to that side, or are we going to take the 7x over to that side? And if I take the 7x over to the left-hand side, I'm going to end up with a 2x minus 7x, which is going to give me a negative. On the other hand, if I take the 2x over to the right side, I'm going to get a 7x minus 2x, which will keep things positive, which is a bit easier. So that's what I'm going to do. I'm going to go 14 equals 7x minus 6 minus 2x. Now I can combine my like terms over here to get 14 equals 5x minus 6. And now I can solve this the way I solved that very first equation I had, where I'm going to get 5x equals 14 plus 6, which is 20. Now I divide both sides by 5, and I get x equals 4. Next, let's talk about fractions. Now again, there's going to be 2 different types of equations we're going to solve here. The second one a bit more difficult than the first one. Let's start with this fraction. Okay, the first general rule is whenever there's a fraction, you can imagine that the whole numerator and the whole denominator have brackets around them. So it's not going to make a huge difference in this question, but in general, it's a good habit to get into to start thinking about it like that so that we don't make mistakes with more complicated questions. The way I'm going to solve this one is by starting, again, with moving the things away from the x that are furthest from it. So if I was solving this, I would go first, I would do x times 9, then I would add 2 to that result, and then I would divide the whole thing by 4, which means 4 is furthest away from x. So I'm going to start by multiplying both sides by 4. So I'm going to multiply both sides by 4. That's going to give me, on the left-hand side here, 4 divided by 4 is 1. So I'm just going to get 9x plus 2 equals 5 times 4, which is 20. Now I can minus 2 from both sides to get 9x equals 18, and divide both sides by 9 to get x equals 2. We might have a more complicated situation with fractions where we actually have 2 fractions. So let's say we have this 2x minus 3 over 2 plus 4 minus 3x over 6. And let's say that that all equals 4. In this situation, I have these 2 fractions there. The easiest thing for me to do is going to be to combine them to form one fraction, and the way I'm going to do that is by making a common denominator. So I have 2 and 6. The lowest common denominator between 2 and 6 is 6, because I can notice 2 actually goes into 6. So this bracket on the left here, if I again put brackets, sorry, the fraction on the left there, if I put brackets around the numerator, I can then multiply both sides of the fraction by 3, which will give me, let's expand the bracket as I go here, 3 times 2x is going to give me 6x. 3 times negative 3 is going to give me a negative 9. That's going to give me that over 6. And now that means I can combine this, and it's all over 6. Now I can proceed as I did on the last slide, where I multiply both sides of the equation by 6. That will get rid of the 6 on the denominator there. And so I will end up with 6x minus 9 plus 4 minus 3x equals 24. I'm going to proceed like I always do. Now it's more or less a straightforward linear equation. Let's combine my like terms. So 6x minus 3x gives me 3x. Negative 9 plus 4 gives me negative 5 equals 24. I'm going to add 5 to both sides, so I'm running out of space here, but I'm going to get 3x equals 29, so x equals 29 over 3. And it's a bit of a messy fraction. It's easiest to just leave it like that instead of writing it as a decimal. That would be my answer. Okay, those are all the different kind of permutations of linear equations that we might get, obviously with different variations here and there. The general things I want to point out, first of all, with brackets, remembering that it might be easier to expand the brackets. If I've got, secondly, if I've got variables on both sides of the equation, then I want to start by moving it so that they're all on one side of the equation, and trying to keep it positive if I can. And lastly, with fractions, if I've got more than one fraction in the equation, then often the easiest thing to do is to create a common denominator between all the fractions in my equation, and then I can combine them to multiply the whole thing by the denominator to get rid of it. Okay, let's finish this video off with doing a worded problem. Let's look at this example. In a basketball game, Dion scored twice as many points as Daniel, and their combined score was 5 points less than the opposition. If the opposition scored 50 points, how many points did Daniel score? There's 4 steps that we're going to go through when we solve questions like this. The first step is to assign a variable to the value that we're interested in. So the question here is asking us for the number of points that Daniel scored. So I'm going to label Daniel's score as X. I'm going to underline Daniel's score, and I'm going to label that as X. The second step is then to write an equation that summarizes the information in the question. So if X is Daniel's score, Dion scored twice as many points as Daniel. So Dion's score would be 2x, double as many as Daniel's was. And their combined score, so if I add those two together, this is Daniel's score and this is Dion's score. If I add them together, the result is 5 points less than the opposition. Now, this might confuse you. The word less there, in your mind, you would automatically translate that to a minus, except let's think this through. If their combined score is 5 points less than the opposition, then they need an extra 5 points to make it up to the opposition's score, and the opposition's score was 50. So I get x plus 2x plus 5 equals 50. Translated into the information in our question, that means Daniel's score plus Dion's score plus another 5 would equal what the opposition scored. So step 1, assign a variable. Step 2, write the equation. Step 3 is now solve the equation. So I'm going to combine my like terms to get 3x plus 5 equals 50. So x equals 50 minus 5, which is 45. 3x equals 45, which gives me that x equals 15. So that's step 3, solve the equation. Step 4 is very important. It's not enough to leave it like that, because the question didn't ask us to find x, it asked us how many points did Daniel score. So I always need to finish a question like this with answering the actual question. So Daniel scored 15 points. Okay, that's it for this video. There'll be a couple of questions up on Connect that I would like you to try and bring to class on Monday, please.